2, 1. So another test, okay? So this one is on logarithm components of functions for grade 11. If you have gone through all the videos I made on grade 11 logarithms, then huge thumbs up to you. I bet you most teachers will not be covering that topic. It typically might get shifted over to possibly advanced functions or another course that you might see. But I feel like logarithms are super useful and students should know them. Anybody who's going to go into sciences, math, technology, computer programming, anything of that nature, it's very useful to know logs, right? So logs are inverses of exponents, okay? So people are familiar with exponents, and sometimes they might even study exponential functions, but they don't really push themselves on logs as much, which is a mistake. So here is a test. Now, like all the tests I do, I'm going to put a link in the show notes to the test so you can download it for yourself and then do it, and then come back and then see the solutions that I provide. So I'm going to go through the solutions. There are basically 5 questions, so it's not a very long test. Personally, I will tell you, I got, I guess, maybe a little exhausted because I worked really hard on all the components for logs. I would recommend that you watch the videos in particular. Try the videos on, for example, log properties. Okay, go over that one in terms of just trying to see more examples. Actually, I'll put up a link above to those log properties there. So that's that. And then the other one, which is super useful, is just being able to solve equations that have logs in them for an unknown. So I'll put up a link to that, which is more practice for you. But if you were following my grade 11 kind of playlist, you would have been doing those before already. Okay, let's kick it off. So question 1. I'm going to copy this question down, bring it right here, like I normally do, and let's try to tackle this. So it says, evaluate the following set of functions at the input provided. Do not use a calculator. So basically, we want to be able to just compute it on our own without any calculator. So this just tests your understanding of properties and how logs actually work. Okay, so the first one, which is this one right here. So so the input itself is t, so probably t for time. So we're going to substitute 16 into this. So we're going to say, okay, so this is f, okay, of t. Okay, well, that's just a 0 there because I have 0, 1, 2 for the functions. And we're substituting in here 16. So if we do that, we get 3. So this is 3 log of base 4 and 48 times 16. All right. Well, so actually right away what I'm going to do is I'm going to kind of divide this out here. Okay, let me leave the 3 outside, and I'm going to use just properties here. Okay, so this is log 4 of 48, so plus because it's multiplication, log 4 of 16. And so here, well, 48, is that 4 to the 3? So 4 times 4, 16 times 4, yeah. Okay, so that's going to be actually 4 to the 3. And this, well, this is just 4 to the 2, okay, because, 16 is. So the entire thing, so that means log of base 4 of that, and then log of base 4 of that. So that's pretty simple now. So this is 3. This becomes 3, because this drops to the front. This drops to the front, plus 2, and there we have it. So this is going to be 3 times 5 equals 15. So that's the first one. Okay, second one right here. Okay, for any x greater than 0. Okay. So we have to have that greater than 0. Oh, but it's minus. So notice this is minus. So this actually won't be bad. I'm just guessing here, but so if I bring this down, let me copy this down, and let's see what we get. So this is for any x, okay. So log of base 2, and this is 2x over 8x because of the minus. Well, the x's actually cancel, and they will cancel. Notice this is for x greater than 0. So we don't have any problem here with the x's. So this x here will just cancel each other off. So what you're going to get is log of 2, and this is just 1 over 4. That's all that is. Actually 1 over 4, so log of base 2, this is 2 to the negative 2, right? Because that's what, so 2 to the negative 2 equals to 1 over 4, which is just, because this equals to 1 over 2 squared, which equals to 1 over 4, which is exactly what we had inside there. So that means the answer to this is just negative 2 for all of x greater than 0. That was actually a cool question. Okay, so let's take a look. So we're just pounding away here at these properties and using them, hopefully wisely. So here's the last one. Okay, so this is at n for n equals to 5. Okay, so let's substitute. So f2 for 5, so it's going to be 3 log of 5 of 5 plus 2 log 5 of 5. Okay, well then this isn't bad. Okay, so this right here equals to 1, and this equals to 1. That's from the log properties. This is just 3 times 1 plus 2 times 1, which is going to be 5. There you have it. So that's question 1. Let's take a look at question 2. So here's that question. That's a long one. Okay, so we're given a function. What would be the parent function of f of x? Okay, well, it's logs. So actually notice f of x equals to negative 2 log of 2. Okay, and this is, it's a sketch f of x by hand. So that means, okay, we're going to have to use some transformations here. So I'm going to put it into our form for transformations. Minus 3 plus 1. So this really kind of looks like this. This is minus 2 and f, okay, of negative 2 is going to be x minus 3 plus 1. Okay, so here are our transformations. So we're going to have to, okay, so we're going to have to do all of these. Okay, so the negative 3, or the 3 and the 1, those are just translations. And then the negative 2 and the negative 2, so those are going to be compressions or stretches. So our parent function actually, so our parent function for this really is just log base 2 of x. So that's our parent function, right? Now, okay, so that's A. Now we have to sketch this, so it won't be super easy, but let's give this a shot. Okay, I don't exactly know how the whole thing will look like, but I do know. So this is x. Okay, so this is y. So my original one is going to look something like this. This is the parent function, so it's going to look something like that, right? It's going to continue this way. It's going to get close to that. Where the domain is x greater than 0 for this parent function, and then the range is everything. Now, since we have, okay, so first this 2, okay, so what do we know about that? Well, for transformations, okay, so with that 2, we know is going to be stretching it in the y. All right, so that's what's going to happen. So it's going to stretch this out in the y a little bit. Okay, so that's what's going to happen here. So that's that. And so I'm just going to, you know, try here. So it's going to kind of, yeah, so it's going to kind of look like that. I'm going to stretch it out more like this. That's the 2. Now it's going to flip it as well. Okay, I'm going to worry about the flipping after, because so that negative, so this negative, okay, so that's going to be a reflection in that x right there. So we know it's going to get flipped, but I want this -2 right here. So this, so the 2 itself, so that's going to be, I guess, another, okay, so that's going to be, in the x, it's going to be compressing it back in, okay? So it's going to shift it over, so in terms of a sketch, so now, okay, so if it's going to be shifting it over in this way, so it's going to be kind of like this. Okay, so it's going to be kind of like that. Okay, so it's going to compress it back into this direction. And now I'm going to do the reflections. So the first reflection, so this minus, so that means this is going to go now in this direction. So it's going to go kind of like that, right? That's the reflection in here. And then this reflection, because it's also negative, that's going to reflect it in the y. So now it's going to be looking something like this. Okay, so that's going to be going in this direction. And now it's going to be translated. Okay, so it's translated by 3. Okay, so it's going to go 3 to the right and then 1 up. Okay, so it's going to be going 3 to the right and 1 up. So I'm going to delete all of these guys, so I don't want to see them, and not to clutter this. So 3 to the right, so it's going to go this direction by 3, and then 1 up, 1 up. So it's going to be, I guess, kind of like this. So something like that. And it will have an asymptote here. Okay, so it's going to have some asymptote right there. We're going to have to try to find that. Okay, so that's going to be, okay, so this is kind of our sketch. So this is kind of how it looks like. We're going to have to try to find. So we're going to try to find this point and also this point. And then we're going to try to find that asymptote as well. I do believe, yeah, so here it says find the domain and range of the function. So finding the domain, so what we have, so to find the domain, I guess it translates it over by 3. So our domain, so notice it's going to be, our domain is going to be all of these values. So it's going to be less than 3. And again, if you forgot, okay, so what we need is we need -2 x minus 3 to be greater than 0, right? That's what we need. So now dividing by -2 on both sides, I mean, it's going to flip this over, but it's going to be x minus 3. And now notice x and then 3. So that is my domain. So the domain, it's a set, so x is all of R such that x is less than 3. That's my domain. And my range is going to be all the values. So my range, y, is going to be all the values. There are no restrictions there. All right, because it's a log. Now, it looks like, you know, it tails off here and it looks like it might be approaching something. But logs just kind of grow at a very slow pace because remember, it's an inverse of the exponential, so it's just going to grow at a much slower pace. But it still has a range of all the values. And so that's my domain and range. Now find the x and the y-intercept, okay? So find the x and the y-intercept. Let me go back here. Copy. Paste. So you can now solve this. So first, okay, so if we set x is equal to 0, we're going to find the y-intercept. So we're going to be able to find this point right here. So if we do that, what do we get? So f at 0 equals, so this is -2 log of 2. Okay, it's 0, so it's going to be 6 and then plus 1. All right, so whatever that comes out to be, let's see. So -2 times log, actually this is log of base 2. Okay, so hold on. Let me just rewrite this again using properties. So this is going to be log of 6 divided by log of 2. That comes from the properties. We have to multiply -2 and then plus 1, like so. Okay, so I'm going to swing this over. So let's first do the log. So log of 6 divided by log of 2 equals, okay, so that's that, times, this is going to be -2. Okay, so far I've did this times that, and then plus 1. Okay, so this is -4.1699 and so on. You can round it, but that's this point right here, okay? This point right there that you see. That's where it should be crossing it, okay, the y. Now we need to find this point, which is the x-intercept. Now this one might be harder for us. So let me paste this back again. Now in order to find that, that means that happens at y is equal to 0. Okay, so that means we're going to set this equal to 0, and now we're going to have to solve for x. Okay, so that's a nice exercise here. So let's bring the plus 1 over on the other side. So it's going to be -1. Now this is log of 2. Okay. Dividing both sides by -2. That's like that to get rid of this junk. That's going to be just a half here. And I'm going to get log of 2. All right. So now I'm going to try to solve. So I'm going to make the base equal to 2 right here to get rid of that log. So I'm going to do this. So 2 to the half and then 2 to the log of base 2, which is going to give me 2. Okay, so this is 2 to the half, which is really just square root of 2 equals, and then this is -2x plus 6. Okay, so we're getting there now. And now, so move this over on the other side. That's going to be 2 minus 6. Okay, so we have that. Now divide by -2 on both sides and you got your x. -2. Okay, and that's your x. And let's see what that is. So again, so 2 to the exponent of 1 over 2 really is just the square root of 2. That is, you know, you should understand the fractional exponents. Minus 6. Okay, so that's going to be that. And then that answer divided by, I guess, -2. So this is approximately 2.29 and so on and so on. So that's this point. Let's go back here. That's this point right there. So it's on the positive side, and then it just kind of blows up and gets closer and closer towards 3. So my asymptote right here happens at x is equal to 3, right? That's the asymptote that it's going to be approaching. So perfect. What is the okay, so what is the asymptote? So that's what I just said. And now plot f of x by using a graphing tool. So let's do that. Okay, I'm going to try to plot it and then see how close we actually were. And let's take this out. Okay. So I have, okay, so function. So this is going to be, we have -2. So -2 times, okay, so now we're going to put log, so miscellaneous. This is log of base, okay, of base 2. And that was of -2x plus 6 plus 6. Okay. And plus 1. Plus 1. Ha! Perfect. Okay. Let's take a look. And let's take a look at these. There we go. -4.17. And then this one was 2.293. Which is, let's see what we got. -4.1. Yeah, because we got 167,999. So that's rounded. And 2.29 and so on. Okay, so that was this one, 2.29. Okay, perfect. So that's kind of how we sketched it out. Okay, notice this is how it looks like, and then it just starts growing. So it goes like whoosh. So that's just utilizing transformations to be able to do that. All right, so you can take a look at the transformations for logs. You can put a link up above there if you've forgotten it again. Okay, so that was question 2. Let's take a look at question 3. So here's question 3. Solve the following equations. So we have 2 of them for the unknown. Provide the admissible range for the solution if it exists. Okay. So let's take a look and see. Okay, so this is 1. Now the first thing that I'm going to do is, so this is for part A. So I need to make sure that, okay, so this right here, okay, so this right here, so this has to be greater than 0 for logs, right? And then, so that's the admissible components that we will run into. Okay, so let's see what that gives me. X plus 1, so this has to be greater than 0. Now, so for that, okay, so in order for that to be greater than 0, now it's the cubed root, okay, of this. I mean, I can cube both sides, I guess, and it's going to give me x plus 1. I'm going to have to be careful here. And that gives me greater than that, so that means x has to be greater than -1. All right, so that's what I'm going to have in here. And so this is what we have. Now let's take a look and try to see if we can solve this thing. Okay, so solving, now it's log. So if it's log, then what I'm going to do here, let me move this out of the way, shrink it. So I'm going to raise both. Okay, so I'm going to keep the base as 10. Okay, so like this. So this is going to drop this down. So this is x plus 1 equals 2, 10 to the 0.2. Okay, and now, so I'm going to cube this. So if I cube this, it's going to be x plus 1 equals 2, 10. Now it's going to be cubed. So I'm going to cube both sides. So this is just a number on the right-hand side. So really, this is just 10. 0.2 times that is 0.6. X plus 1. So x equals 2 minus 1. So let's see what that gives me. So 10 to the exponent of 0.6 minus 1. Okay, so it's approximately, so 2.981 and so on. I'll just keep, okay, that. So that's my answer. Now, it's within my admissible range, so it's definitely greater than -1. Now, so this admissible, okay, so this range which has to be greater, so this right here. Let me just plot this, okay, for us. And I'm plotting it, honestly, because I myself am curious here. So, okay, we want, this is cubed, and then inside we have x plus 1, is it? Plus 1, plus 1. Okay, perfect. So notice, so we needed this, okay? So we can't have negative values there. So that means indeed, okay, so that was at -1. That's how we got that admissible range there. And then the solution was 2.981. All right. So that's part A. Part B. So this one, let's see what this is. I'm going to take this, copy. Part B. So paste it back. Oops. Okay, so first admissible range. So what do we have here? So this, these are funny ones, but we must have x 0.5 has to be greater than 0, and then x to the quarter has to be greater than 0. Well, so for both of these, basically we're just saying x has to be greater than 0 here. And the same thing here, right? Because you can, 0.5 is the same thing as x to 1/2, which is the square root of x. So if you square both sides there, you're going to get x is greater than 0. And then on the other one, you can take it to the power of 4 on both sides. And again, you're going to get x is greater than 0. So we have to have an answer which is greater than 0. Now, trying to solve this, so I right away see the negative here. So I'm going to bring these together. So this is going to be x, okay. This is a half, because it's the same thing as 0.5, over x to the quarter equals to log of 100. This is just 2, right? Because this is 10 to the 2. So this is going to be just equal to 2. And now we can group this together. That's going to be log of x, I guess this is a quarter because it's 1/2 minus 1/4 equals to 2. Now raise it, so take the base of 10, which is going to give me x to the quarter equals to 10 to the, well, this is, I guess, back to 100. So that's what we have there. And now, so what we're going to do is, okay, so this is the same thing as saying this, right? That's that. So what I'm going to do is, I'm going to, so take this to the 4, this to the 4, and it's just going to give me x is equal to, and this, the answer is going to be monstrous here. So that's my answer. So that's, 100 to the power of 4, and clearly that's bigger than 0. That's a monster answer for that. Okay, so I mean that is just saying this times that times that times that 4 times, right? So this is saying is, so my answer is that. Monster. Okay, so that was question 3. Okay, so question 4 says you have decided to invest $10,000 at a rate of 21% compounded annually. So basically this is an exponential growth type of example. So you've seen this before if you've studied exponential functions. You can look them up in my list for grade 11. If you want to have $1 million, then how many years would you have to wait for that to happen? Okay, so, to set this up, I mean, this is just an exponential growth. So that means this looks like this. You're starting off with 10,000, right? It's an exponential growth where your rate, R, is 0.21. And then this is N, I guess, because number of years. So I'll switch this to N. But in this case, we actually know what we want to have at the end. So at the end, we want to have $1 million. So what we're doing is we're trying to solve now this equation for N. That's what we're trying to do. And in order to do that, we're going to have to use logs, right? Because we're trying to find the exponent. Okay, so let's do it. At least this question won't be that difficult in terms of solving. So first of all, you're going to divide by 10,000 on both sides. Okay, so to get rid of this, because it's in front of the bracket, the N applies on the bracket. So that bracket is going to stay. But now, so notice this. This is much easier to try to see. Okay, so it's going to be 1.21 to the N. And now, so this is in the exponential form. Now you can switch this to logs, right? So you can take the log. So because I want to know what this is, okay, so then this is just going to be N is equal to log, because you can take the log of both sides. So the base is going to be 1.21 of basically 100. That's what you will have right here. Okay, so now solving this, so log of 100 divided by log of 1.21, or you can use ln, right, the natural logarithm, if you wanted to. So you can do that as well. And what does this give us? So log of 100 divided by log 1.21. Okay, so it's 24.158 and so on. So this is approximately 24 years. That's how long it would take. That's not bad. Now the only problem is, of course, this is, you're assuming that you're getting 21% growth on your money, which is going to be, it's going to be hard to try to find an investment like that, but this is how it would work. All right, so 10,000 to $1 million. So that was question number 4. Okay, so last question on this test. So a virus has been contained within a town over the last year. If currently there are 18,000 infected people, then how many half-life periods would it take to bring the number of infections under 500? Okay, so half-life. So half-life is a decaying exponential problem, right? So it's exponential decay, where the rate is 50% because it's half-life. And so in order to do this, okay, so you may again, so recall, so the half-life is kind of set up like this, where we have our initial amount. Now, in this case, our initial amount is 18,000. So half-life, so it's 1 minus 50%, which is going to give us a half, right, or 0.5. And then this is the number of periods that it will take. Now they're saying we want to get down to 500. So we have something like this. This is the problem that we're going to have. I'll switch this to 0.5. And now you're solving for n again. So you're going to do just the same thing as you did for question number 4. So this is just an application of trying to see how we would be able to solve this. Okay, so let's do that. So I'm going to divide both sides by 18,000. And so I'm going to get whatever that is. Okay, so you have 500 divided by 18,000. Okay, You know what, I'm going to keep this. Actually, hold on a second. Let me just do this. So it's going to be 5 over 180. And 5 goes into 180. Let's do that quick. 36. So this is just 1 over 36 equals 0.5 to the n. Okay, so that's my problem. So now again, you're trying to solve for the exponent here. So you can take the log of both sides or just transfer it into the log form. Okay, so what that's going to be is you're going to have log of the base, 0.5, of your answer, right, which is this. Now, if you want, I'm going to use ln, since we didn't have it actually in this test at all. So this is the same thing as saying ln of 1 over 36. So I'm just switching the base. That's the property I'm using. You can use log if you want of this. They're going to give you the same answer. So let's clear this. So ln, this is 1 over 36 divided by ln of 0.5. Okay, so approximately, let's just round this. So this will take approximately 5 periods. So 5 half-lives to bring it down. Now, whatever that half-life, we don't know how long the time is. They don't tell us here, but that's what that would be. So these ones are actually kind of great application questions, and being able to solve them is pretty neat. Okay, so that ends it. I wonder how many questions you got. So thank you for watching. I hope that this was helpful. See you in a future video. Bye, everybody.